Module 3.3, we go ahead and start to look at an idea called measure of spread and how we measure the what we call variability in data that we have. So this goes with describing distributions of a quantitative data. Remember, we want center, shape, is there anything unusual, and the key piece, and maybe sometimes the most important piece we call variability or the spread. How spread out is the data? So we don't have a complete picture of a data set and what story it's telling if we don't know what the spread is. Is the data really close together or is it far apart? So that's what we're looking at. And so in this first example, what we mean by spread, look at set 1 and set 2. You could see set 1 has a lot of consistent values next to each other. They both have a mean of 80. And then look at set 2, you will see, even though the mean is 80, this outlier really affected the mean. So are these two sets the same, even though they have the same mean, 80? Or are they different? Do they tell a different story? So I really need you to pause and really think about that, right? Set 1 and set 2 have the same mean value, but the values in the sets are really different. Some are close together, and then these are definitely close together, and they have one outlier. So because of this characteristic, right, and sometimes not knowing what this is, we have to come up with ways to measure that. And so in statistics, one way we measure spread, right, or variability, that key word there, more fancy word, is through range, right? That's one measure. Just like a measure of center, we measure spread. How do we know how far something's spread out? Well, one way is we use a max minus the min value, and then you get a value. That's it. That gives you the measure of spread. There's a drawback to this because it's only using two values within the data set. All the other data sets are ignored. All the other data are ignored, max minus 1, but it's a very simple way of doing it and is useful in some ways. Another measure of spread is what's called the interquartile range. It measures the spread of the box in a box plot, or the middle 50%. And what you do is you just subtract Q3 minus Q1. It's beautiful in that they're simple. These both are simple equations, right? Not fancy formulas. We just subtract two values, and that tells us or gives us some measure of how spread out the data is. Now, although we have those two, there are two more, I think, sophisticated ways of analyzing spread, especially with bigger data sets or more complicated data sets. It's through what we call variance and standard deviation. Those two values are connected to each other. We use variance in, I think, more advanced classes. They come up in more advanced formulas. So the spread we talk mostly about in this class is standard deviation, and you hear that term over and over and over again in this class. And it kind of measures on the typical distance the values are from the mean. The formulas are here, and again, just like we have two centers of spread for mean, we have two for standard deviation, where we have the sample standard deviation, just the letter S we use, or the sigma, the Greek letter S we use. The formulas are similar if you take a look. One little difference is we divide by n minus 1 or divide by n, but most cases we never are calculating the population because I don't have the data to do that. I only have sample data, so this is what the computer is doing, is sample data. And what we hope is somehow the sample standard deviation is connected in some way or tells a story for us with the population standard deviation. And in order for that to happen, statisticians learn that to be a good approximator, instead of dividing by n, how many data points are in the sample, divide by n minus 1. And for some mathematical reasons, this is a better estimate for the population standard deviation. It's more accurate. And so when we think about it, we're going to be using the term standard deviation. Most of the time, it will be with respect to sample standard deviation because we have sample data.